pH. pH is really just a measure of hydrogen ions. We use the pH scale in order to determine the pH of a solution. Therefore, we're going to measure the hydrogen ion concentration inside of that solution. The hydrogen ion symbol with the bracket around it indicates the concentration. If we were going to put a value on the pH scale, it's going to run from 0 to 14. Anything from 0 to 6.99 is acidic, 7 is neutral, and 7.01 to something that measures 14 would be considered to be basic. Each step in pH is 10 times the hydrogen ion concentration or hydroxide ion concentration. Therefore, if you move from, say, 3 to 4, that's 10 times as strong. If you move from 3 to 5, that would be 100 times as strong because you would move 10 times from 3 to 4 and 10 times from 4 to 5. Thus, 10 times 10 is 100, giving you 100 times stronger. If you went from 3 to 6, as you might imagine, that would be 1,000 times as concentrated. Buffers then are basically chemicals that are going to resist changes in pH. They convert a strong acid or a strong base into a neutral one. Your body has many important buffers that we'll speak about more when we get into the respiratory system and the urinary system. Acids. If something is considered to be an acid, it is because it's going to dissociate in water to form hydrogen ions. Dissociate simply means that it will break down in water and it will give up hydrogen ions. Acids are sometimes called proton donors. You may remember from looking at the periodic table that hydrogen ions have one proton. Therefore, if it's dissociating in water, yielding hydrogen ions, it is essentially donating a proton. Bases, on the other hand, will dissociate in water to form hydroxide ions. Sometimes bases are considered to be proton acceptors, again because if that hydroxide ion takes up a hydrogen ion, let's say we end up with water. This is just a picture showing you the difference in materials and where they fall on the pH scale. If you look off to the left, you can see that there is neutral at 7. As you travel to the top of the picture, you get more basic or more alkaline. And again, at the bottom, you're going to become more acidic. Off to the right, you can see the different acidities of everyday substances. You don't need to memorize these numbers, but it is helpful to know which are either basic or acidic. This picture here shows you, A shows you an acid. If you have hydrochloric acid, you can see that when it's in water, it's going to dissociate to yield hydrogen ions, and then of course a chloride ion as well, but the hydrogen ion is the one that's going to contribute to the pH. Potassium hydroxide is the base. You can see that in water it will dissociate into potassium ions and hydroxide ions, and again it's the hydroxide ion that is going to contribute to the alkalinity of the solution, or the basic part of the solution. And we'll get to the salt in a minute. If you take an acid and a base and have them react, they will form a salt. So for example, we have hydrochloric acid, which is the HCl. That's going to bind with potassium hydroxide, which is the KOH. That would be our base. That will yield us potassium chloride, which is a salt. That's the KCl, plus H2O, which we know is water. A salt, then, by definition, is something that is going to dissociate in water to form a cation and an anion. Remember that a cation is a positively charged ion, and an anion is a negatively charged ion. Now if you look at C, the salt situation, we've got the potassium chloride. We'll put that into solution and yields a cation, which is the potassium, and a chloride ion, which is our anion.